Now see here, a toroid has a core of inner radius 25 centimeter, outer radius 26 centimeter. So we can write R1 is equal to 25 centimeter and R2 is equal to 26 centimeter. So here we can calculate it here, we have to convert into centimeters. So this is a meter, sorry, that is 2.25 meter and R2 is equal to 0.26 meter. Now number of turns N is equal to 3500 and we have to calculate the, given the current is also, that is 11 ampere. Now we have to calculate magnetic field. So now see, we have already done inside the empty space of the toroid there is magnetic field is 0. So in the part C, in the empty space surrounded by the toroid, the magnetic field is 0. Already we have discussed all these things in the case of the toroid. And also the outside the toroid magnetic field is 0 because there is no net current enclosed by that loop if it is drawn. Similarly, if the loop is drawn inside the toroid, their net magnetic field, net current is 0. Now see about the second part, inside the core of the toroid. Inside the core of the toroid we can calculate, and that will be coming B is equal to mu naught Ni, and here we can write B is equal to mu naught N divided by 2 pi R2 into I. 2 pi R we can take, not R2, that was R2 in case of the derivation of toroid. We can write here R is equal to the average value of these two. So we can solve it here now. 4 pi into 10 raised to power minus 7 into 3500 into 11 divided by 2 into pi into, in place of the R we can write 0.25 plus 0.26 divided by 2. This 2 will get cancelled, and where you can solve here, put the value of here the T, that is the Tesla. Now we can solve this pi and this pi we can cancel, and on solving we will be getting here around, that is 3 into 10 raised to power minus 2 Tesla. So this is the magnetic field here inside the core of the toroid. Now we can calculate, you can easily calculate this part. So this is about the toroid here.